Have you ever stopped to think about what's actually happening when you type? You press a key, and a letter magically appears on your screen. It seems simple, but there's a fascinating bit of engineering going on right under your fingertips. Let's pull back the curtain and see how your keyboard actually works. So, you press the G key. What happens next? Underneath that keycap, you're not just pushing a button. You're completing an electrical circuit. Imagine a grid, like a spreadsheet, made of wires. There's a set of horizontal wires and a set of vertical wires. These wires don't touch each other, at least not at first. This grid is called the key matrix. At every intersection of a horizontal and a vertical wire, there's a potential switch, which is right under each one of your keys. When you press a key, you push a conductive pad down, connecting a specific horizontal wire to a specific vertical wire. This closes the circuit at that unique intersection. Think of it like connecting a dot on a graph by drawing a line from the x-axis and the y-axis. Now, how does the computer know which circuit you just closed? This is where the keyboard's own little brain comes in, the keyboard controller, which is a tiny microprocessor. This controller's job is to constantly scan the key matrix, and it does this incredibly fast, hundreds of times every second. The scanning process is pretty clever. The controller sends a tiny electrical signal, a pulse, down one horizontal wire at a time. While it's sending the pulse down, say, row number 3, it's also listening for a signal on all the vertical columns. If you haven't pressed a key on that row, the pulse goes nowhere, and the controller hears nothing. It then moves on to the next row, row 4, and does the same thing. But let's say you've pressed the G key. When the controller sends a pulse down the specific row that the G key is on, that electrical signal now has a path. It travels across the switch you just closed and down the vertical column that the G key is on. The controller detects this signal on that specific column. At that moment, the controller knows the exact coordinates of the key you pressed. It knows, for example, a signal came in on column 6 while I was sending a pulse to row 3. It then looks up this coordinate, row 3 in column 6, in its internal chart, which is called a character map. This map tells the controller that this specific coordinate corresponds to the letter G. This isn't just for letters, of course. The same process happens for the Shift key, the Control key, numbers, and function keys. When you press a combination, like Shift plus G, the controller detects two circuits being closed simultaneously. It recognizes this combination and knows to send the code for a capital G instead of a lowercase 1. Once the controller has figured out which key or key combination you pressed, it converts this information into a standardized code. This code is called a scan code. It's a universal language that the keyboard uses to talk to your computer. The controller then sends this scan code to your computer, usually through a USB or wireless connection. Your computer's operating system receives the scan code and says, "Okay, I've got scan code 4G. It then tells the program you're using, like a word processor or a web browser, to display the character G on the screen. And all of this, from the moment you press the key to the letter appearing, happens in just a few milliseconds. It's an incredibly fast and efficient system of scanning, detecting, and translating. So the next time you're typing out an email or a comment, remember the hidden dance of electricity happening beneath your fingers. It's not magic, it's the elegant engineering of the key matrix and its controller working together to turn your physical actions into digital communication. Thanks for watching. If you enjoyed this peek under the hood of everyday tech, consider liking the video and subscribing for more. See you in the next one.